Hey everybody, Dr. Pingle here, demonstrating a technique, whether this is the best technique or not, but I don't know, but one that we've had a lot of luck with here in our lab for pulling together RGB and thermal images. In this case, this is a flight that I did over over Binghamton University, and we've got a single grid of nadir imagery, and then 4 different angles of obliques. The ultimate goal for this is to tie it to LiDAR, which I'm not going to demonstrate here. But just sort of how do I build a nice thermal mesh out of this? So step 1 is to run the RGB images, as most people know. So this is a standard project that's complete through phase 1. All of these are pretty typical parameters, so I left the key points at full. These are just default stock mapping settings, so nothing interesting going on here. When you run this, though, what you get is the output. And as part of that, I use Pix4D mapper to do this. As part of that, you get several sort of configuration files, and one of those files is this one, which contains information about the final location and orientation of the camera when it was taken. So what you can do with this is use that to seed the thermal, which is kind of the novel part here that I don't see a lot of other people doing. Now the thermal is tagged with, all of those images are geolocated as well. They are the RTK GPS. The gimbal provides orientation information. So there's a lot of information already in those tags. What this does is it lets you just sort of skip that step and effectively just imagine that you want to use the RGB locations as the thermal locations. Now, you may not want to do that. For that to work, you have to assume that the camera images are taken at exactly the same time, or close enough to it that it's fine. In this case, I've demonstrated to my satisfaction that the Mavic 3T must be very, very, very close. I haven't worked out exactly how close, but I think pretty close. I suppose that would be a topic for another thing to try to demonstrate that those are actually the same. But we've gone to the trouble of overlaying, one thermal image matched to the RGB, and it's really right at the center. They line up perfectly. A previous project that I worked on with the Mavic 2 version of the thermal drone, that was not the case. They were clearly off center and clearly taken at different times. So, whether this is precisely the same time, I couldn't tell you yet. But I can tell you that the images center pretty much exactly the same, with one caveat that I'll explain here, which is that the time stamps do vary a little bit. But I think that's only just I think that seems to be a time stamping issue as opposed to a drastically different time. Anyway, let's take a quick look here. So the file that we're interested in is this one, and you can see from the preview that we've got the name, not the path, which is nice, but just the name. These are the RGB JPEGs, longitude, latitude, altitude, omega, phi, and kappa. So pretty much everything that we need. What I do with this is I copy it and I place it, a copy of it right here, and then this is the copy that I edit. This is that file. These are all the JPEGs, and what I do then is just to find and replace the underscore v.jpg with underscore t.tiff. Now, why underscore t.tiff? If we look at the images that we're working with here, go back. Oops, go back here. The thermal images come in as JPEGs, and they look like this. So these are radiometric JPEGs, but the actual metadata that lets you make it radiometric is tagged in the metadata and has to be basically applied to the data that's in the pixels themselves of the payload. And there's an image map, or color map, I should say, that renders these out. So it looks like a regular sort of thermal image, which is great, but there's actually recoverable radiometric data in here. Now, doing that conversion, there are a couple of different ways to do it, but the way that we do it, the way that I do it, is to use the DJI image processor 1.1. This is on GitHub, and it's free, at least for now. Really great. We've got the ability to tune these things, which I'm not going to do here at the moment. But basically batch processing. So you point to these JPEGs and you hit go, and what you'll get is a pile of radiometric TIFFs, geotiffs, right? So these are what I want to use for the reconstruction. Now, it doesn't look like anything here in the preview, but if you loaded these in ArcGIS Pro or loaded it with a Python image reader, you would see the payload in there, and it's actually like float values here of what it estimates the temperature to be. And I'll just say again that is dependent on the settings that you just saw here. So if you don't get these right, then the temperatures aren't going to be right. So it is kind of important to take thermal GCPs or to take ground measurements that you can then sort of do a sanity check to make sure that the numbers that you're getting out of this conversion actually hold water. I'm not going to get into that here. We're just going to focus on the construction part, but it's well worth mentioning that you shouldn't just be able to hit go and trust that these values are right. You do have to tune these to get them right. But I'm actually not interested in that at the moment for this project. I just want to show relative hot and cold. I don't really care what the actual values are. So the defaults are actually fine for me. So if you go back into the file that we've made here, we're just going to replace that .jpeg._v.jpg with _t.tiff, and we can just go ahead and replace those. Now, if you look closely at the file names here, you can see that it's stamped with basically a date and time, but they're also sequential. Now, the interesting thing here is that the file names for the JPEGs and what are now TIFFs for the RGB and the thermals don't precisely line up, and the reason for that is the sequential numbers don't always have exactly the same timestamp. They do in 95% of all cases, and we'll see that here in just a second. But there will be a few that don't. I haven't looked into this in enough detail. I've been because the numbers here are large enough that I haven't just hunted this down. But one reason that might happen would be that they aren't taken at exactly the same time. Another reason for that might be the timestamp associated with them is somehow not quite the same. And for a fraction of these that sort of fall close enough to halfway up to the next second or whatever, and get rounded up or down, you could wind up with a difference of what looks like a second of the timestamp, but it's actually only microseconds or whatever, milliseconds. So I'm not paying that much attention to that, although I'll note that that's a potential problem. Okay, so when we want to create a new project then with those TIFFs, what we're going to do is just start with a normal new project. All right, forgive the time jump here, but I didn't want to waste time for that dialog box to load, and I've just added these here. It's a new project. We're going to add images to that, as of course we must, and so I will find those geotiffs. Great. I've got 1,800 or 1,867 of these. Moderate size project. Just go ahead and let this dialog box run. Okay. So I'm going to go ahead and let these stay stock. So I don't particularly care about this camera model. It's something that I might get into in a future video here. But the crux of this is to use the from file here. These are going to come in as longitudes first. I don't know if you remember that from what we just looked at, but longitude is first on this list. And we'll hit OK. Make sure that I saved those, I suppose. All right, so we'll hit OK here, and we'll load these up. Should just take a moment to come in. Now, what you're going to see is that some of these don't match, and the way that you're going to be able to pick that out. There's actually a couple of ways to do this, but one of the things that I like to do is to set that. What's going to end up happening here is I'm not going to use the images that don't match. Now you could go through, and we've done this before, and just match them. But if you don't want to do that, and you feel like getting 95% of the images is enough, I've got 1,800 images, so I don't need every last one of them. So I'm going to tag the altitude to 0, and then I'm going to load that file again. And the reason for that is I only want to use the ones that have been sort of previously calibrated. I don't want to use anything else. And what that's going to do is that everything that did match is going to show up in here as a valid altitude, and the ones that don't are going to show up as 0. So that gives me a way to sort of quickly just eliminate the ones that I don't want. And as you can see, it's really not all that many. I'm not going to count, but I can just disable those, and then I can just keep the ones that do matter. Again, you can go through by hand, and it's not all that difficult to automate if you were doing a lot of these. But for me, I could just let those handful of images go. All right, so I'm going to choose the standard maps profile here. And I don't need any of that stuff. I really only need step 1. Now you actually can go through and you can just use this setup to export a point cloud. I'm not going to do that. I'm going to generate. I'm going to do what's recommended by Pix4D, which is I'm going to merge the RGB with this one and use the RGB to develop the spatial model, and then just texture that with the thermal model. So that's the standard approach that Pix4D recommends. So I'm not gonna demonstrate that either. But I guess if somebody has a question about how that works, maybe it will. All right, I always tune these down because I don't want to blow up my processor while I'm doing other things. Now the cool thing that you can do here is to set the external. We can set this to accurate geolocation and orientation, and then your external parameters can be set to none. What that means is that I'm not going to be using any of the. I'm not going to be trying to figure out where it is or which direction it's pointed. I'm going to assume that whatever I'm getting from the RGB is correct. And again, there's some good reasons to think that that might not be absolutely true. What I've seen as I've done this is that it's clearly close enough to do a good job. It lets me merge the projects together. Everything lines up just perfectly. So I don't have a problem with this. But if you do, you probably are adept enough to figure out how to work through those issues and dial it in just a little bit further. I'm going to leave this on automatic. I'm not going to use geometrically verified matching, although in some cases I will do that if things don't work out. By the same token, if things don't work out, checking the free flight or terrestrial might be a thing that I would do. But I don't really have any reason to expect that this isn't going to work. I do have some obliques. I think those obliques were taken at, I don't have my notes handy here, but something like 20 degrees off of nadir. So I'm not that worried about it. I think free flight is probably going to be fine. I don't like to generate an orthomosaic because I don't care about that orthomosaic, and it always takes up time that I need to do something else. So I think that this is good the way it is. So we'll save it. Just as an aside, sometimes I like to save the version that I'm actually going to run as a separate file. It's a little bit of superstition back from the older days of Pix4D when you couldn't just rerun the step one and get the exact same thing as if you ran it clean. So that gave me the ability to kind of go back to the original setup of the project in case I wanted to make any modifications without having to go through the whole 5 minutes to set up a project. So I'm happy with this. We'll go ahead and hit go. And this should work. I'll pause the video. We'll take a look at the output. So we'll see you on the other side. Okay, this run is complete. Took about 8 minutes. And all of the 99% of the images calibrated. There's a few disabled here that we got rid of. And otherwise, you can sort of see just from step one that the overall quality is fine. Keep in mind that A, these are key points, not a real point cloud, and B, that these aren't going to be used to generate the spatial structure anyway. So the next step then, save that project. This is already saved, so we don't need that. But then we can create a Pix4D project and merge those two together, and we'll just demonstrate how that portion works. Okay, so we'll create a new project. And we'll add these two. We can delete this one. We don't need that one anymore. I had moved these images around, so we'll just point those back. Definitely don't want to treat these as identical. I don't care about that. We'll finish that project. And this is going to do the standard sort of merge queue of work. So it's going to run through some things. So we'll just wait for that to finish. That doesn't take too long. Okay, with the merging complete, the next thing that I'd like to do is to add a couple of manual tie points to this. Most of the time, these will be reasonably well tied together, but it doesn't hurt just to get a sense of how well that's been done. So if you take a look here, you can usually find structures in the landscape. I really like to use manhole covers are often show a pretty good signature in this case. We can look for some of these, in a grassy area. So here's one. Here's a grate right here. And you can see that pretty clearly on the thermal images as well. This a grate probably wouldn't be my top choice here, just sort of picking these things at random. But if you can get two of them in here, then you can hit apply, and you can start to get a sense of how well this is doing. So when I'm doing manual tie points, I'm not usually trying to locate centimeter scale features here, because you're not going to be able to necessarily see those on the thermal. So you're looking for things that are big enough to kind of stand out clearly on both image sets. So like I said, manholes generally fit the bill for me. And you just kind of, some advice. You want to keep kind of labeling these until they correspond nicely on a wide variety of the images. Once you get to the point where you can kind of look at these and say, yeah, that seems like they are lining up, then you're in good shape. And so, you want to pick a few of these throughout the scene. In this case, this is a relatively large scene, so I'd probably, 5 at a minimum, but, you could do 10 would be fine. But whatever's going to get you good sort of reasonable spatial coverage over the entire thing. So I'll pause the video. I'll create some of those, and then we'll come back before the final render. Okay, so I've got 6 manual tie points. You could add a few more here if you wanted to. I'm satisfied enough with this. So we'll make sure that project is saved, and then re-optimize the project. Okay, so that re-optimization is done, and so now it's time to move on to the next step. Always a good idea to just sort of check things out and make sure that things look good. One of the things I'll mention is a lot of these rooftops actually have really great features, things that show out really well on the RGB, but things that also show out really well on the thermal. And I'll just show you an example. So a lot of these stacks coming out of the ceiling, or out of the roof, I should say, actually show up really nicely on both. You can find things that are going to be clear on both. And the nice thing about rooftops is they're not obstructed by anything. So in addition to manholes, rooftop features are often really good here. Okay, so let's move on to steps 2 and 3. We'll just take a quick look at this here. On step 2, I always like to export as an LAZ. All of this stuff can be whatever you want. In this case, I'm going to export as high resolution. And then this is the critical one. So what you want to do is your point cloud is generally going to be created using the group 1, which is the RGB images, and likewise for the mesh geometry. But for the mesh texture, you're going to use the grayscale. Now the reason for this is I'm only interested in the thermal mesh. If you're interested in the RGB mesh, then of course you can export that as well. In my case, I've got a LiDAR scan that I did just an hour before this, and it has all of the spatial information that I care about. And I'm actually going to fuse those two things together. So the only thing that I care about is the thermal mesh. I actually don't care about the point cloud either, but we'll export that as well. Over here, you can check these exports for whatever you like. This is giving me a 5 centimeter image, 5.6 technically. A lot of times I'll round this off to an even number, even if it doesn't quite support it, just for sanity's sake. So in this case, I might round that up to 6 or round it down to 5. It's not going to make a huge difference either way. It does take a lot longer to produce something high res than low res. The difference between 5 and 6 isn't that significant, but the difference between 5 and 10 can be. So, think about what you'd like here. So we'll do 5, and just check this down, and we're good to go. In some cases, people care about this radiometric product on the back end. I really don't, but we'll export that as a 5 centimeter index as well. So we'll just hit go here and pause the video and wait for that to complete. Okay, so Pix4D is done. Sorry for the rough jump there, but Pix4D is done, and I've loaded the mesh. So the mesh output comes from there we are. So in the merge, densification, and 3D mesh, so I've loaded the object file, in this case into Cloud Compare. And so white, by the default rendering here, just white is hotter, and black is cooler. Now these have been sort of hard coded basically into the materials. So there's actually a JPEG here that gets written with the values. So if you want to visualize this on your own, then you can go select the mesh. You can go to let's see here, Tools, Edit, Mesh, and then convert texture material to RGB. This will take a moment, so okay. And then if we go to colors, we can convert that to a scalar field. In this case, I'll just use the composite. And now we've got a value here that we can play with. So the active scalar field is the composite, and then this is set to blue, green, yellow, red. So sort of a default, but you can change that to whatever you want. So blue, white, red would be an interesting option. But the point is, excuse me, now you get a chance to adjust the color scheme however you like. So in this case, this is the Binghamton University campus. We can turn on or off different shaders depending on whatever you like. So I had the EDL shader on, which I think adds a good bit of depth. And of course, you can see things like the rooftops are very hot, the grassy areas and trees are relatively cool. You get a chance to see sort of that certain building tops are hotter than others. You can see that certain sides of buildings might be hotter than others. So in this case, the north side of the building is cooler than the south and west sides. The west side in particular, I was sort of imaging this in the late afternoon, and so the west side of the building is the hottest, I would say. And the north and the east side should be relatively cool. So lots of interesting stuff with these 3D visualizations of temperature. Hopefully that's a bit of a walkthrough. Constructed here for someone that I know, but hopefully this is of use to many of you out there. All right, thanks.